Good morning. Today's lesson is on margin of error. This is in Unit 3 for statistical studies, the third lesson and the fifth assignment in this unit. So let's get started. Let's go to bell ringer real quick. The bell ringer is, in 1936, a magazine called The Literary Digest ran one of the biggest opinion polls of all time. It asked 2.4 million people whether they planned to vote for the incumbent Democratic president, Franklin Delano Roosevelt, or his Republican challenger, Alfred Landon. They trumpeted this prediction that Landon would win 50% of the vote and Roosevelt would lose with only 43% of the vote. So the poll must have had one of the smallest margins of error in polling. Now, think about this. We don't know what margins of error is. We're learning what that is today, but I want you to know something. This was wrong. Error margins apply only to the population of pollsters sampling. Now, keep that in mind. We'll talk about sampling errors in another lesson, but the margin of error is something we're going to look at very carefully. Now, what actually happened in the election? Roosevelt he won by landslide, 62% to Landon's 38%. Why do you believe the election results were different from the poll results? Here's what I want you to think about. Who did this periodical, this magazine, who did they sample? Who did they ask? Okay. So if the Literary Digest has a readership of a lot of Republicans, there's a very good chance that the Republicans that voted or would vote for Landon or that subscribe to this magazine would say that they'd vote for Landon. And that's not a good sample. Even though it's 2.4 million people they surveyed, it's not a good sample of the entire voting population. You need to make sure you have every different demographic of your voting public in your sample before you can actually conduct what's considered a good sample of the population of voting people. So that's one of the reasons why it didn't work. So, all right. So what's your good things? My good thing was I got to eat good turkey. It was a lot of fun. Not turkey. I'm sorry. We eat hen. We had 2 chickens, cooked it all, stuffed my face. Probably gained about 3-4 pounds. Didn't watch any football. Got some work done. Just, enjoyed my break. So hope you guys did too. Hold on just a second and let's get into the lesson. All right. So statistically, it is impossible to sample an entire population of registered voters. So a sample of voters are polled or given a survey of their possible vote. Now, of course, since only a small portion of the voters were selected to take the poll, it cannot be a precise prediction. Therefore, statistics provides a way to calculate what's called a margin of error for surveys. Now, margin of error, and I would suggest you memorize this definition, is an amount which is usually small that is allowed for in case of a miscalculation or change of circumstances. Okay? It's supposed to be almost infallible the closer you get to an election. But the margin by which sample may be wrong is calculated by statisticians to give an expert opinion to the results of a surveyed sample of a population. So it's supposed to make up for any error. So you should be able to predict stuff with a margin of error. If the margin of error is small enough, you can predict the results according to statistics. So recall the study from Student Activity Sheet 1 that analyzed scalp hair samples from 22 participants with epilepsy and 23 without it. They checked for differences in levels of copper, zinc, iron, magnesium, and calcium, and the results are summarized in the table below. So look at this carefully. Now, if it were possible to measure the presence of copper in the hair samples of all males with epilepsy in the world, do you think the average would be exactly 14 micrograms per gram? And explain your thinking. So I want you to think about this. That sample of 21, that's how many we had? 22 epileptic participants. Is that a fair sample that represents the entire population of epileptics around the world? That's what you need to think about. And 14 is fairly close. Others may think it could vary widely due to other factors, especially if one remembers that small sample sizes. Okay, some may also point out that 14 is most likely a rounded value anyway. And you know what? That's possible. I think that is a good way to describe why it's probably not a good or a large enough sample. This journal article that contains the results of the study actually reports that the males with epilepsy have an average of 14 plus or minus 9 micrograms per gram of copper in the scalp hair. What do you think 14 plus or minus 9 means in this situation? It means exactly what it says. It's plus or minus. So it's 14 plus 9 to 14 minus 9. So think about that for a second. At least perform the computation, 14 plus 9 and 14 minus 9. You should get the numbers 23 and 5. And you might incorrectly believe that these are the highest and lowest values in the sample. Those are not the highest and lowest values in the sample. That's a statistical calculation based on all of the samples they got. Because the sample size is so small, that means the margin of error is going to be very large. Small sample, big margin of error. Large sample, smaller sample of error, okay? The plus 9 is supposed to be plus or minus 9. It's called the margin of error. The wording, however, does not mean that someone messed up the research. It means that no sampling method can guarantee that the sample exactly matches the population, but that the sampling techniques, when used correctly, can be trusted to give results that are accurate within a certain range. So the margin of error is a range of the result. Since the males with epilepsy in the sample showed an average of 14 micrograms per gram of copper in the scalp hair, the researchers are fairly confident that the true average copper concentration for all males with epilepsy in the study is somewhere between 5 and 23 micrograms per gram. Now, have you ever seen a news report that mentions margin of error? And what was the report about? Many of you probably saw this. There's political poll results that mention margin of error. Now, notice in the bell ringer, we talked about political poll results. All right, look at this. Politician Paul and candidate Carl are running for governor, and the election is next week. Now, the latest poll shows that politician Paul has a 46% of the vote, while candidate Carl has 43% of the vote. And the news report, however, states that the poll contains a 3% margin of error. Now, 3% means that it's plus or minus 3%. What does this mean for politician Paul? Well, politician Paul has 46%, so we're going to add 3% and subtract 3% from his poll results. So he should get as little as 43% or as much as 49% of the vote. Well, how about candidate Carl? Well, he has 43%, so that means it's plus or minus 3 to the 43, which means he can have as little as 40% or as much as 46%. So as you recall, 43 to 49, and this is 40 to 46, there's a 3% overlap. What do you think that means about the poll results for the upcoming election? So if you think about it, the race is too close to call. Paul can win by as much as 49% to 40%, or Carl can win by as much as 46% to 43%. Neither person is predicted to obtain 50% or more based on this poll, so there's likely to be a runoff, depending on the actual election results. Remember, they only took a sample, so if everybody voted and the sample size is small, there's a good possibility you'll get a clear winner. All right, recall the study from Student Activity Sheet 1, question 19, that tested the effect of replacing rabbit's soybean diet with Gliricidium sepium leaf meal, or GLM. The rabbits were randomly assigned to receive either 0, 5, 10, 15, or 20% GLM in their food. And the resulting effect on weight gain is summarized in the table below. So weight gain for 0% is 958 plus or minus 40, 5% GLM is 887 plus or minus 59, and so on. And this increase in weight during an 8-week period measured in grams. So fill in the interval of the true mean weight gain for each treatment. And based on these results alone, what do you recommend to the farmers in the area and why? Now, notice that each one of these has its own separate margin of error. Like the 0% has plus or minus 40, 5% has plus or minus 59, and so on. The larger margin of error means the smaller sample. Well, let's look at what the results mean. The true mean weight for 0% is between 918 and 998. That's a pretty large, that's 80 grams, okay? And 5% is even vastly larger. That's over 100 grams. That's 118 grams difference between the lowest possible and the highest possible in the true mean weight gain. 10%, it's kind of narrow, it's 48 grams, 968 to 1,016 grams. It would result in the highest average weight gain. And then 939 to 1,005, a little bit lower than the 10%. As you can see, The lowest in the 10% is 968, which is above the lowest in the 15%. Still below the highest in both. It's actually above 5% highest, so it would remain probably your best choice. 20%, it actually lowers the more GLM in the food, it lowers the weight gain. So what do you think you should recommend to the farmers in the area about this particular study? A 5% mixture does not seem promising. You see that it's really low in weight gain, but a 10% mixture does, okay? Now, let's reflect. Increasing the concentration of GLM in the rabbit food decreases the cost of the food. Now, could this change your recommendation to the farmers? And if so, why or why not? Now, think about this. The more GLM, the more food, or the less the food costs. So you don't know how much money would be saved, but it might be worth sacrificing weight gain if it saved enough money. Sadly, that sometimes is what happens. So I'm going to launch you with this information. This is a pretty good schematic. It's right off of, I don't normally poll Wikipedia, but these results I've also found in Encyclopedia Britannica, which is where I think I actually gleaned these. But I want you to look at the difference between the actual results and the final poll. In the final poll, Donald Trump in November was slated to only get 42% of the vote, and Hillary Clinton was supposed to get 46% of the vote. Both of them were off. Donald Trump got 4% more, and Hillary Clinton got 2% more. Both of the other two candidates got less than they were expected to get. So anyway, margins of error, when you look at the election polls and the end of the election results, these results are from samples of the voting population and are subject to vast margin of errors, mainly because it's really hard to get a good demographic sample of all of the voting public, population of the voting public. So anyway, that's the end of the election. Make sure you look into the Google Classroom for the assignment under the same name, SAS3 margin of error. Take care of that. That's going to be a daily grade. In the meantime, those of you that are watching, be blessed, be a blessing.